So we're going to look at all the different concepts that we have discussed regarding the calculus of polynomials and look at some examples. So first of all, we have seen how to find the derivative of a given polynomial. So in a very generic way, let's say that we're looking at this polynomial and we want to find f prime of -1. Okay, so what do we do? Again, please pause the video and try to solve this problem and check the solution now. So f prime of x will be the derivative of x cubed, which is 3x squared. And then I need to take the derivative of x squared, which is 2x, and multiply it by -7. So remember, it's this little game that we play. We find the derivatives of all the powers of x, and then we multiply them by the corresponding constants. So the derivative of x squared is 2x. 2x times -7 is -14x. And the derivative of x is 1, so 5 times 1 is 5. And the derivative of 1 is 0. And now, when we find f prime of -1, then we need to just plug in -1. And this will be 3 plus 14 plus 5, which is 22. So from this, we could deduce that the graph of f of x goes up at -1. Why? Because the slope is positive. And this is the slope of the tangent. So again, we might want to recall that we have the graph of our function, and then at a given point, we draw the tangent. And it's really the slope of that tangent which is what we call f prime of a, this being the point a comma f of a. So if somebody asks us, for example, in the instance that we just did, what is the equation of the tangent? So what is the equation of the tangent at -1? And when we say -1, we might as well find f of -1 so as to know what the point really is. So if you plug in -1 in the original function, what do you get? You get -1 to the third, which is -1, minus 7 times -1 to the second, so that's -7. So -1 minus 7, that's -8, plus 5 times -1, so -5. So -8 minus 5, that's -13, plus 1, that's -12. So the value of the function is -12. And what is the equation of the tangent? I remind you the general formula. Y minus f of a is equal to f prime of a times x minus a. So what is it for our case? Y minus -12, so y plus 12 is equal to 22 times x minus -1, meaning x plus 1. And that's the formula. We can leave it like that, or we can actually simplify it. So y is equal to -12 plus 22x plus 22. And this will give us y is equal to 22x plus 10. it would be useful to actually pause the video and try to redo the example. So turn the video back and try to redo the example a few times till one gets used to it. Now, the second thing that we did was to be able to find antiderivatives. So we asked something like this: what function do we take the derivative of in order to come up with 6x to the fourth minus 5x cubed plus 4x squared minus 6x plus 2. Okay, so it doesn't get any more interesting than this, I guess. So please pause the video and try to find the antiderivative, or an antiderivative for this to be more precise. So how do we do it? Again, the idea is to find the antiderivative of the individual pieces. So here we have number 1. So this would be x to the 5th over 5. So remember, you go 1 degree up, and then you multiply by that degree. Now you divide by that degree. For x cubed, it would be x to the 4th over 4. For x squared, it will be x cubed over 3. For x, it would be x squared over 2. And for this, it would be x. Now you just need to multiply it by the numbers that you have in front. So here's our answer. It would be 6 over 5 times x to the 5th minus 5 over 4 times x to the 4th plus 4/3 x cubed minus x over 2 is the same thing as 3 minus 3 times x, x squared, I'm sorry, plus 2x. And that's it. Okay, that's an antiderivative. Again, please pause the video and try to do this several times. So this is the second standard task that we gave. Then we define the definite integral. And of course, we have cases where nothing much needs to be used in order to compute the definite integral. So let's say that we have this is, let's say, the graph of y is equal to 3 minus x. And so this is 3, this is 3. And let's say for the sake of the argument, we wanted to go just up to 2 and ask the question, what is the integral from 0 to 2 of 3 minus x dx? Can you answer this question without using any knowledge of the fundamental theorem of calculus? Please pause the video and give it a try. And here's the answer. Yes, this can be done because we're looking for the area of this trapezoid. This trapezoid has one base, which is this one. This is equal to 1. And it has another base, which is equal to 3. So what is the area of a trapezoid? It's the average of the two bases. So 1 plus 3 is 4 divided by 2 is 2 times the height. And the height here is 2. So final answer will be 4. That's how much this integral is. And this could have been done in a different way. So you could have also split this trapezoid into a rectangle, one that has one side equal to 1, the other equal to 2, hence its area is 2. and one right triangle, which has two sides equal to 2, and that has also area 2, so 2 plus 2 is 4. So you can do it either way, meaning exactly because you know that the definite integral is the area between the graph and the x-axis. If you have a means of computing that area, then you can compute the integral. And that, of course, happens in the case that we have a simple geometry for our graph. But for the cases that nothing like that is possible, we resort to our heavyweight, the fundamental theorem of calculus. So we have, let's say, an example that looks like this. We have the integral of x cubed minus 3x squared dx from 0 to 2. Let's try to compute this. So please pause the video and try to compute this integral by finding an antiderivative for the function inside the integral, and then taking the difference by plugging in 2, plugging in 0, and taking the difference. So let's see how we do this. We first ask the question. First step, always ask the question, what is an antiderivative for the function inside the integral, which is called the integrand? And the answer here will be, as we saw before, 1/4 x to the 4th minus the antiderivative for x squared is x cubed over 3. If you multiply by 3, you will get just minus x cubed, right? So all you need to do here is to do 1/4 2 to the 4th minus 2 to the 3rd, and then subtract from it what you get by plugging in 0, which is of course 0. But rewrite it so as to make sure that we see everything. And 2 to the 4th is 16, divided by 4 is 4, minus 8, that's -4. So the final answer is -4. And of course, at this point, one might wonder what in the world is going on here. And the simple answer is that the negative parts of this region between the graph of the function and the x-axis are going to be larger than the positive parts. I'm not saying that we know in advance whether the function has positive parts altogether, but if it had, then they would be smaller than the negative parts. And again, it might be a good idea to rewind the video and try to redo these examples as many times as needed so as to feel comfortable with them. And that's it. Thanks for watching.